Hello, in this video, I'm going to talk about the box and pointer diagram of scheme lists. It's also called the box diagram for short. So in scheme, we can build lists using a very fundamental construct. It's called cons pair. So if you do cons 1 and 2, then it gives you a pair, and that this is a notation, it's a dot. So each cons pair has a first part, which is can be retrieved using car, and then the second part can be retrieved using curter. So that's it. So this is the fundamental building block, and with this we can build all kinds of structures, trees, lists, and so it's really the only data structure we have, and that makes it a lot easy to once we learn how to process lists, we can process all kinds of data structures using those three procedures. So list scheme also has a convenient procedure called list. So it builds a list for us. So it looks like this. It's a flat list, but internally, it's actually use cons. It's a set of cons pairs linked together. So the box diagram allows us to understand this more clearly by looking at the internal structure. Oh yeah, so now with this list we can build list of lists, and then again if we use cons, and then it's gonna give us this. So this dotted pair, this notation that shows that this is really a cons pair, is not a list. So then the question is, what is the difference, or what is the relationship between cons pair and the list, right? So we could build a list using cons pair. So I'm gonna build the same list using cons pair. All right, so cons 2, okay, cons 3, cons 4. Then I need to end it with a list. Okay, so as you can see, a proper list, something like this, is really a sequence of cons pairs linked together. So the first it's overall is a cons pair. The first part is the first element, and then the second part is the remainder of the list, and then the remainder of the list is another list whose first part is 2, and then the remainder of the list is another cons pair, all the way to the last cons pair, which has the first part of an element, that is element, and the second part is empty list. So a list like this is called a proper list. It's a sequence of cons pairs linked together, and if you trace the curter, it always points to an empty list. So, and the textual notation is this, right? In the console, you can only print text, so that's what we have, we see. And then let's see, if I change the last one, this is no longer a proper list, and then the textual notation representation is this dotted pair notation. Okay, so now let's look at the box diagram to see how the internal structure of this list. So I'm going to draw so I'm going to have a pair. Okay, so the first, okay, so this is where list starts. We have 1. The first part is 1. The second part is a pointer to another pair, and then the first element is 2. The second is the remainder part, is the remainder of list, which is another cons pair with the first one being 3, and then the second being another cons pair, and then the first part is 4. Okay, and then the second part is an empty list. So we could do this. Okay, so use empty list notation, or we could use this. Okay, so two different notation, that means the same. So this is the internal structure of a proper list. So there's always a backbone that ends with an empty list. Okay, so and it's, as you can see, it consists of cons pairs. Okay, so then the question is, how do we visualize a list like this? Let's see, two and then another list, because lists can be nested, right? So this is the flexibility. This is how we can build all kinds of data structure using list, using cons pairs. We can build binary trees, build all kinds of things. So okay, so how do we draw the box diagram for this list? Well, first of all, it's a proper list. We don't see the dot, right, and then before the last element in the list. So this tells it's a list overall. So there's a backbone. So it starts with a pair. And the first element, the first part is going to be 1. Okay, so how many elements do we have at the top level? So it's 1, 2, and 3. So we have 3 cons pairs on the backbone, and then it ends with a empty list. Okay, so the second element is 2. No, okay, the third element is 4. Okay, so what is the second element? Well, the second element is a list itself, right? So what is a list? It's a sequence of cons pairs. Actually, I'm gonna draw it longer. So it's a sequence of cons pairs with a backbone that ends with empty list. So we have, how many do we have in this list? We have 1, 2 elements. So we're gonna have 2 cons pairs. Okay, so and then it ends with a empty list. The first element is a 2, and then the second element is another list, 3. Okay, 3 is a list by itself. It's a list of 1 element, right? So that's the second element in this list. So since it's list, proper list, so if we have a backbone, but there's only 1 element, so it's just 1 pair with a empty list, and then the second, the only element, the first and only element is 3. Okay, so this is the box and pointer diagram for this list. So whenever you see something like this in your mind, you can imagine it's a nonlinear structure like this, and then it looks complex, but with it's really just consists of cons pairs with the 3 procedures, cons, car, and curter. We can construct and then destruct, right? Take it apart using those procedures. So I'm gonna write some code to build this list for us. So first of all, I can use the list, this convenient method, right? So this procedure to list 3. Okay, so that's another list, and I have 4 that makes up the overall the top level list. Okay, looks like this. So if I use the translate the cons the box diagram, I can say cons 1, and then cons the first one is what is another list, right? So start with the cons. The first one is 2, and then another pair cons. I'm right here, which first part is a cons 3 with the empty list, right? So we're done with this one, and then this curter is empty list. So let's put actually I don't use empty list like this. So now I need another empty list, and then that finish this cons, and then that's the so that's 2. Okay, so that's the cons. Yeah, so 2. So this finish that pair, and then that one I have a hold on, so this cons. Oh yeah, I forgot something. The first part is cons. The second part is yeah, so cons, we're looking at the second box, right? The first part is the cons 2, and this part, and then the second part is what? It's another cons, right? So let's write cons. Its first part is 4, the second part is an empty list. Okay, so as you can tell, I need to finish all the braces. Okay, this is a lot harder to write, right? But the result is the same. Okay, so the list procedure, this is really convenient, but we also need to understand behind the scene, the internal data structure is just a set of cons, pairs, linked together. Okay, so I hope this is helpful.